Alright, we're busy with exercise number 1, and we have done this already, but we're just going to recap. They ask us here the following, and I want you to sit with a highlighter and do as I am doing if you haven't done this already. Alright, can someone borrow me a highlighter? Sorry, I have it. Okay, so consider the following relations, determine whether it is functions or not. So that is the first thing that you need to answer that question. Alright, that is the first type of question. Then further you need to write down the domain and the range. So in actuality there's how many things that I need to answer? There's 3 things. For each graph I need to say, is it a function or not? And then I need to write down the domain. Now the domain is my x values and the range is my y values. Alright, is everyone with me? So what do I do? Here I have a set of ordered pairs, and I told you last time, go and write down, here it is -2 and -1. That dot right there is -1 and 0. -1, sorry, and this one is 0 and the y value is 1. I'm writing it in terms of x and y. This is the coordinates that I have there. Alright, and then I have here further, this one is 1 and the y value is 2. Alright, so is this a function? For every, how do I know if something is a function? I do the vertical line test. So I take a ruler, I take the ruler from left or right. If it cuts the curve or the set of ordered pairs only once, then it is a function. Alright, so if I go from left to right, yes, now I answer this question here. Yes, it is a function. That's what I did there. Alright, and now I need to write down the domain, and the domain consists, is x element of what is the values that I have there. I have all of these values, -2, -1, 0, 1 and, alright, so we write down there, it's -2, -2, -1, 0, 1 and 2. Then, so not 2. I do apologize there. Just checking if you're doing the right work. Okay, and then we have y is element of, now I'm going to use all the smallest. So how do I get these values? I go from my x, I go from left to right like that. If for my range, I go from the bottom to the top. Okay, so that is also in the booklet that you could have written there. So I'm going to write, this is now going to be, it's that -1, and then it's 0, and then it's 1 and 2. Alright, so this was supposed to be your homework if you didn't complete it. So I'm just going to write down the answers now. Yes, I said this one is a function. Yes, the domain is x, its element from -infinity to positive infinity. How do I know that? Because there's arrows indicating for me that it goes on forever and ever. Alright, then the further from that I have here, which is x. Yes, this, alright, so the range is y from, it starts from the bottom to the top, and we still have it's -infinity to positive infinity like that. Is everyone good with that? Alright, so let's say this one, is it a function? I check for every y value, I go across, yes, it is a function. So now I write domain, and then I write the domain is x is the element from -2 until +2. Okay. Just note there that there isn't really a dot there or something indicating to me that it stops there. But if there was a dot colored in like that, then I would have changed this brackets to a more like a block type of bracket. Alright. Remember when we did earlier the year inequalities, and we said that x is equal to, say, let's 1 or less than 1. That means I'm going to use, what is that? That is x is greater than 1. No? So what do I do there? I say this means if I was to draw this on the number line, I would have said that if I draw the number line like this, say I have 1, 2, and 0 here. Where will x be? Yes, this reads as, what does this reads as? It reads x is greater than 1. So it means if I have the like that. However, if I put in the greater or equal sign, then I need to include that 1 as well. Alright? So then it needs to be a colored in one. However, for this one, it's not colored in, so I leave it like that. Is anyone has an eraser for me, perhaps? So let's just fix that and an eraser. Ooh. It's fine, we got it. Alright, so let's just fix that. That's -2 until +2, because that is, however, not included to me. Alright, so if I go further, is this one a function? I said yes, it is. The domain is x is element from what? X element from -infinity to +infinity. In this one, the range is y is an element of what? 1 until infinity. Okay. So here I told you to please extend this to, what is that number? That's -4. Alright. It's so there you were supposed to put in -4, and here you were supposed to put in 5. Did you do that for me? Okay. So then if we look at this values here, we're gonna say yes, it is a function. The domain x is element of what? Bracket -4. Now is this, now you see, because that bracket right, that dot right there is just like this one. However, if this one was colored in, I should have been not a round bracket, but a more square bracket. Alright, so because we didn't color it in like that, so it's going to range from -4 until what is the biggest x value? 7, like that. Alright, now we do the y. This is the range, so the range is going to be from where? -1 until 5. Alright, so this thing is a circle, and a circle is not a function. Okay, not a function. And what is the domain of this? X element of -3 till +3. Then y is an element of -3 until +3. Alright, so this one, it is the function, and I told you this is the introduction to the first function, which we call the hyperbola. Alright, did you write there? His name is also familiar as the hyperbola. And this one, just make a note there, aka hyperbola. So that's his name. We will also learn him throughout this year, or while we are doing functions. So we say this hyperbola here, and we say yes, it is a function, and then we go write down the domain. Let me just get a little bit more space. Yes, the domain is going to be x is an element of what? -infinity. But what happens here? It reaches down and then it goes down forever and ever, but it never crosses this y-axis. Alright, so it goes until 0. And then once again it continues, it starts again here on the other side of the 0, and it goes until infinity again. Alright, so that is what we have there. And just a side note for you, this is what we call a asymptote. So what does that mean? We'll get to it on a later stage as well. It means that the line reaches x, or the x values reaches y, but it gets to very small, but it never touches or crosses the y axis. So, and the same happens with the x axis. The range of this one will therefore now be y is an element of what? Of -infinity, if we're going from the bottom until the 0 there. So going from the bottom, it starts there, it goes up until there, but it never crosses the y-axis, and then once again it goes further from 0 until +infinity, like that. Is everyone cool with that? Cool. Then this is a straight line, but it's not a function, so we say no, because it has multiple values at a certain point. Okay? Alright, so if I go from left to right there's no value for that values there, but here by 3, it has a lot of values there by 3. Okay? So what is so it's not a function, because if I do the vertical line test, it shows me that there's more than, at a certain point, there's more than one value. Alright, so when we say the domain of this one, so the domain, I go from left to right on the x, so the domain will be only x is an element of 3. X is an element of 3. Or you could have written this as x is equal to 3. Okay? And then the range, it ranges from, it goes here from the bottom until the top. So the range is now is equal to y, and is an element of negative infinity until positive infinity. Alright, so that's what was that first part. Let's continue now. Let's go into the page number 6. Mapping and functional notation. Alright, so I want you to sit with a pencil or a highlighter. Since functions are special relations, we reserve certain notation strictly for the use of dealing with functions. Alright, so we say consider the function dealing with, let me just find a ruler for you guys to see, dealing with functions. Consider the functions f of x where y is equal to 3x. This function may be represented by means of mapping notation or a functional notation, which looks like f where x is equal to 3x. Alright, this reads as f maps x onto 3x if x is equal to 2, an element of the domain, then the corresponding element of the range is where we substitute the 2 into the place of x, and that gives us an answer of 3. We say that 6 is the image of 2 in the mapping of f. Alright, functional notation is the one that's quite important. I want you to highlight for me there, functional notation. Functional notation, I want you to highlight for me. If we look at functional notation, we are actually talking about f of x is equal to 3x. Now this f of x is actually just y being equal to f of x. So f of x is just another name for a function, and we use this f of x sometimes to distinguish between different functions, because it can be g of x, it can be h of x, something, just to indicate the various functions that we have to our disposal. Alright, so this reads as f of x is equal to 3x. The symbol f of x is used to denote the element of the range which x maps. In other words, the y values corresponding to the x values are given by x. In example, y is equal to f of x, you see? So it's the same as that. You can highlight for me that as well. For example, if x is equal to 4, then the corresponding y value obtained will be by substituting x is equal to 4 into 3x. So let's work that out quickly before we go even further. So there we say for f of x, the y value is 4. So we write down the 4 in the place of x. I substitute there. And then everywhere where there's an x, I substitute again the 4. So we get 3 times 4, which equals to 12. The bracket is a symbol of if, and it do not mean multiplication, but rather the y value at right here, this 4. It means where f is equal to x. So that doesn't mean f times with 4. Alright? This simply just means where this function has an x value of 4. And it does not mean multiplication, but rather the y value at x is equal to 4. Alright, this exercise I've written it down, but it's on my cell phone, and I'm using my cell phone to record at this moment. You can scratch that for me. For now, this exercise I'm going to erase. For now, I'll tell you what exercise to do there on a later stage. Alright, let's go on. The linear function. Alright, aka you can write there for yourself by the linear function, you can write there aka the straight line. All right. The graph of a linear function is a straight line. The equation of the linear function takes the form y is equal to ax plus q or y is equal to mx plus c. That is just different variables used by different people. Now, how we can represent it is the first one is by using the table method, where we sketch the graph of y is equal to x minus 2 by using a table method. And the first values, the top values, will normally be our input values, or what we know is x. And the second part will be where we will determine our y values. All right. So how do I get to this value? I say I use this function right here, and I say where f of x is equal to x minus 2. This thing right here is my function, all right, or this whole thing is my function. Now, how do I get to the value of that? I say f of negative 1, and I say now I'm going to substitute everywhere there's an x, I substitute negative 1 minus 2. So negative 1 minus 2 is equal to 3. So that means my y is equal to negative 3. Do you understand that? And for all of these values, they do the same there. So that is what you are supposed to do if you are given a table method and you go draw it out. Then the x values were randomly chosen, but this is values that I would suggest that you use when you are asked to draw a function. You must use this table, but just include there for yourself the value of negative 2. I would say always work from this table to draw the most basic function. Is negative 3. Negative 3, thank you. All right. Negative 3. And now we say the x values were randomly chosen, the y values were found by substituting the x values into the equation. Now, what is this actually? Let's work out negative 2's value as well, because let's work out the values to the left and 2 more values to the right. So quickly, you can draw it on the page, but do it neatly if you do it on the page. So let's put in the value here. Let's put in just negative 2. So how do I work out that value? I write for myself here, if I put in f of negative 2, it's going to be negative 2 minus 2. And that answer is going to be negative 4. All right. So that's going to be negative 4. And then I'm going to put in another value here by 3. So let's use 3. And if I put in 3, so that means where f is equal to positive 3, it's going to be 3 minus 2, which equals to 1. All right, so that means my y there, where f is equal to 2, my y will be, where x is equal to negative 2, my y will be 4. Where f is equal to 3, my y will be 1. So I put it there. And what is this representing? This is my coordinates that I have here. So I'm going to plot the coordinates, and I want you to do the coordinates with me, the plotting of the coordinates. Where do I get the coordinates from? I say here, as I keep so negative 2 and negative 4. The x, I go on the x-axis. Where's negative 2? There's negative 2. Why? So there's negative 2. I need to go down to what? Negative 4. So I put my first point there. Are you with me? What is my next point going to be? Negative 1. So I go there, I put you see I'm holding my finger there. So it's negative 1, x is equal to negative 1. What should be my y? My y should be negative 3. And then I go on where my x is equal to 0. So this is the point of origin. And what should my y be? Negative 2. So my y should be negative 2, like that. Then I go on where my x is equal to 1. So it's going to be right there. But use your ruler, go down where those two cross each other. Okay, and where my x is equal to 2, my y is going to be 0. Where my x is equal to, where my x is equal to 2 to 3, what did I say? My y is going to be equal to 1, positive 1. So like that. And now all I have to do is I need to draw a neat line covering all these coordinates there. And then I have drawn successfully my first linear function. Alright, so now I can name this function. Alright, it has a function there, there is its name, y is equal to x minus 2, like that. So I will name him as the function is given his name. I'm not going to change Torben's name to something else, alright? So here, his parents called him that. I'm not going to change his name. And you do the same. If you're given a function f of x, you simply just write there what is given to you. Alright, note the line cuts the x-axis at the point 2 and 0. That is quite important. I want you to, the line cuts the x-axis at the point 2 and 0. This point represents the point represents the coordinates of the x-intercept. Alright, for the x-intercept of any line, it is clear that the y value must always be 0. That is very, very important, people. The x-intercept of any line, it is clear that the y value must always be equal to 0. Alright, just checking something. Now, the line cuts the y-axis at the point -0 and -2. This point represents the y-intercept. And for the y-intercept of any line, it is clear that the x value must always be equal to 0. Alright, let's go on and see what we have on the next page. Is everyone still with me? This is also quite important for us. The next one that we're looking at is called the dual intercept method. Dual intercept, and what I would be referring to, in the previous page we just talked about the what intercept? X-intercept, the x-intercept, and also the y-intercept. So dual means two, so they are talking, or they are referring to the x-intercept and the y-intercept. Alright, so the first method in which we can graph a linear function is called, what we had on the previous page is that of the table method. Alright, you should know that it's the table method, and we just did the table method together. The next one is the second one, which is called the dual intercept method, where we're going to plot a function by using the x coordinates, the x-intercept, and the y-intercept. Now we are given the function. Sketch the graph of 2x minus 3 is equal to 6 by using the dual intercept method. Alright, so all of these that goes from here onwards is what you are going to use, and this is just an example, and I'm going to talk you through the example. So for the x-intercept, and that is quite important, you are also going to write it when I give you an example, when I tell you use the dual intercept method and sketch the following function. You are first of all, you're going to write that for me down. X-intercept, let y equal to 0. Then, so that means everywhere in this function we have 2x minus 3y equal to 6. Everywhere where there is a y, I'm going to replace that y with 0. And if I replace the y with 0, I say 2x minus 3. But what is 3 times 0? 0. So that's going to become 2x is equal to 6. And now what I do from here, I want to get the x alone. And how do I get the x alone? I say 2x is equal to 6. I want to get rid of that 2, so I divide on both sides by 2. And then if I divide, 2 times 2 is equal to 1. And this 2 divided by 6 is equal to 3.
Am I wrong if I say square root? Am I wrong?
Alright, so we remember it's a multiplication, it's 2 times with x. So if I want to take it to the other side, it becomes 2 divided by x. So my answer is 3, but what does this represent? This represents where my x is equal to 3, my y will be equal to 0. Alright, So that is the coordinate given to us, and there they tell you the x-intercept is the point, x-intercept is the point 3 and 0, and now I determine the y-intercept, and the steps you need to write down. So the y-intercept I determine, let x equal to 0, and then I say 2 times 0 minus 3y is equal to 6. So 2 times 0, what is the remainder here? It's negative 3y, and now I divide on both sides by negative 3y. What do I get? I get my answer is negative 2. Alright, so once again, what does this tell me? This tells me where x is equal to 0, my y is equal to negative 2. And all I have to do now, I have two coordinates. And for a linear function, you basically just need those two coordinates. What is my two coordinates? Is this, and what coordinate is this? This is my x-intercept, and then here I have my y-intercept. So now I'm going to plot those 2 points on my Cartesian plane. And I do it, I'm going to first plot the x-intercept. So where's the x-intercept? It's here by 3 and 0. What is my y-intercept? 0. Am I going there? Am I going down? Yes. Like that. So that is my, and then I put, that one is what? That one is 3 and 0, and this one is 0 and negative 2. So then I connect those two dots like that. I take my ruler, I connect those dots like that, colon, and then I say, could this line, what is the line or this function given to me? The line was, the special initial one was 2x minus 3y is equal to 6. That is the name of the function given to me. However, please note, this is not in standard form. Okay? So, what further do they tell us? This is quite important. You can make a block around it. The dual intercept method will not work with lines that cut the x-axis at the origin. In this case, use the table method or the y-intercept method, or the y-intercept gradient method. This is quite important, so just make a note of that information for yourself then. Yes, all right. That's good. Now, they ask us investigation, the linear function on page number 9. Sketch the graph of the following linear functions on the same set of axes. All right. So, we are going to first, for each one, we're going to draw a table. All right. So, I'm going to draw the table. I'm going to say f of x is the first one. All right. So, I'm going to say, all right, let's quickly, so I'm going to draw my table. This is my y values, and above that I have my x values. So please use a ruler, don't do it as, where's my, let me just do it right please. What we're going to do now, we're going to draw tables for each of these functions, namely f of x, y of x, and g of x. Alright, so how do I draw my table? I'm just going to draw 3 lines like that, where I have my input value and my output value. Alright, so the values that I choose, I keep the values simple. This is going to be my x values, and my x values is going to determine my y values. I'm choosing the values negative 2, negative 1, 0, 1, and 2. And I'm going to repeat that table for all of this, and afterwards I'm going to work out my function. Alright, I want everyone to draw the following tables for me as we are doing this right now. I'm going to give you a minute. Alright, so I've failed to record, press record there, but we have already worked out these values here. So how do I work out the value? I'm going to just do it again. This is a page that I have to the side there just to keep my work neat. And what we do, I'm going to work out g of x's values for where x is equal to negative 2, negative 1, 0, 1, and 2. So what I'm going to write down is the function, first of all. I'm going to write g of x is equal to 2x plus 2. Then I'm going to say where g of x is equal to negative 2, I substitute the value negative 2 into the place of x. So that's going to be 2 times negative 2 plus 2. And if I simplify this, that means this answer is now equal to negative 2, so that's equal to negative 4 plus 2, so that's equal to negative 2. Alright, now I do the next one. G of negative 1 is equal to 2 times negative 1 plus 2. This is probably going to be negative, this is going to be negative 2 plus 2 is equal to 0. Alright, then I do G of 0, and this answer is going to be 2 times negative 2 times 0 plus 2. So this answer is going to be 2 times 0 is 0 plus 2 is going to be 2. And then the next value is going to be G of 1, and this value will be 2 times 1 plus 2, and that answer is going to give me to 4. Alright, and then I have here for G of 2 is equal to 2 times 2 plus 2, which equals to 6. Now basically what I've worked out here is the coordinates. Alright, so and then I'm going to write these coordinates in. So that is the x value and the y value. Where x is equal to negative 2, the y value will also be negative 2. Where x is equal to negative 1, the y value will also be will now be 0. Where x is equal to 2, the where x is equal to 0, the y value will be 2, etc. like that. And you can always check on your calculator if you worked correctly. Alright, so how do we check on our calculator? We simply just type the function's left hand side right here. So we type 2 times bracket, the value that you're substituting, put it in a bracket like that, plus 2. Okay, so what is the first value that I'm substituting? It's negative 2. Negative 2. So there I checked. Alright, that is right. And now I check the next value. Now I go back. I don't change the whole thing. I just change the values that I'm substituting. I type in negative 1. And then I get my answer is 0. Now I know that I worked correct. And all I have to do now is I can write these values into the table right there. So I'm going to write negative 1, negative 2, and then 0, 2, 4, and 6. Alright, let's do the last one as well. I'm going to use my calculator for the last one just to show you that you can save a little bit of time on the calculator. But I'm first going to write down my function, and my function is h of x is equal to 2x minus 3. So I need to determine the values, and the values where h is equal to negative 2 is equal to. So all I have to do, I'm going to say 2 times bracket closed, minus 3. So what is the first value that I'm putting in? Negative 2. Okay, so there I get my value is negative 7. Just checking if that one is correct. Negative 2, my value is negative 7. What is my next value? Negative 1 is equal to, hold on with me, just wait until we graph this, all of these graphs, because you need to put this on the same axis. Alright, so now I put in 2, and then I'm just going to substitute the values here. So I'm substituting that negative becomes now, it's not negative 2 anymore, it's negative 1. So my value is going to be negative 5. H of 0, I know my value here is going to be negative 3. My value here is going to be h of 1. I think my value is going to be negative 1. My h value of 2 is equal to 1. Alright, so I've rewrite these values here. I have negative 7, and then negative 5, negative 3, negative 1, and positive 1, like that. Okay, so all I have to do now, I'm going to draw the first function, and I'm going to plot these coordinates into the function right now. So let's quickly do that, and then you do number 2 for me at home. Is that clear? Or you would start with number 2, and I'm also going to send you some more exercises to do. Alright, so let's quickly just plot. So the first one is going to be, let me just plot the first one quickly. That's 2x, it crosses by 0, so that's going to look something like this. So let's just use this coordinate and this coordinate. Alright, We just need two coordinates. I'm going to use -2, where x is equal to -2. My y is going to be equal to -4. So let's just make sure that is nice and clear. And what is my other value there? It's +2 and 4 right there. Alright, so I connect those dots like that. I connect those dots with a ruler, please. Running through that and running through there. What is his name? F of x is equal to 2x. Now I use -2 and 2. This is g of x that we're doing now. So g of x is going to be yx is equal to -2. My y will also be equal to -2. So I draw my line there. There's -2. And where my x is equal to 2, my y is equal to 6. Okay, that value is a little bit high. I don't have a 6 here. So let's check where x is equal to 1. Y will be equal to? Where x is equal to 1, y will be equal to 4. So +4. So I connect those dots like that. Okay. And then, so what is this function's name? That is g of x. Okay. And then I'm going to do the next function, h of x. So I'm going to use, I don't have a 7 here, so let's use -1 and, okay, that's not going to work. Let's work 0 and -3. So where x is equal to 0, my y will be -3. Let's use another value there. We can use this value. So we can say where x is equal to 1, y will be also equal to -1. So that means around about there. Is that cool with you? So this function looks around about like that. So I indicate that it continues, and this is the function named h of x. What can we see here? And this is quite important. This is actually what we are investigating now. You can continue with the work now. So what are we investigating now? The investigation here is actually that we're seeing that there's 2x, 2x, and 2x. And those values is the gradient. And the gradient is how steep a line changes. So if the gradient here is the same, then the lines will have the same direction and the same way that they are going in. I want you to do number 2 for me for homework. I'm also going to be sending you more homework on the algebra for you to complete. Please, thank you. Continue with the work now, grade 10.